All right, starting lesson 5.1a using fundamental identities. Grab your yellow chapter 5 summary sheet. You will be using it very often throughout this chapter. All right, starting example 1. Use the values of sine of x equals a half and cosine of x is greater than 0 to find the values of all 6 trig functions. Okay, what's going on here? Well, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Well, we know that hypotenuse is always positive. And here it says that cosine is greater than 0, so that indicates that adjacent must be positive then. All right, now, and this fraction is positive, so that indicates that opposite must be positive as well. So if we're going to construct a triangle, which quadrant should we construct the triangle in? Opposite and adjacent are both positive, so in quadrant 1. All right, opposite is 1, hypotenuse is 2. All right, away, these values indicate that we are working with a 30, 60, 90 triangle. So this is 30, that's 60, so that's square root of 3. All right, now we could answer the question of what are all the 6 trig functions? Well, sine of x is a half, that was given. Cosine is going to be square root of 3 over 2. Tangent is 1 over square root of 3. All right, we have to rationalize the denominator though. And then if I want the other 3 trig functions, I simply take the reciprocal. So it's going to be 2 over 1, which is 2. Here I have 2 over square root of 3. Rationalize the denominator, which is 2 square root of 3 over 3. And the cotangent of x, which is 3 over square root of 3. Rationalize the denominator, and I get 3 square root of 3 over 3, which is square root of 3. All right? So those are my answers for the 6 trig functions. Next example. All right, use the values of tangent. Here I have tangent, opposite over adjacent, and cosine, which is adjacent over hypotenuse. All right, to find the values of the 6 trig functions. Okay, hypotenuse is positive, always. So in this case, adjacent must be negative. And if adjacent's negative, in this case, opposite must be negative as well. So in what quadrant are both opposite and adjacent negative? That would be quadrant 3. All right, labeling the sides, I have negative square root of 3. And then I have negative 3 for adjacent. And then figuring out the hypotenuse, notice that this is a 30, 60, 90 triangle because you just multiply negative square root of 3 times the square root of 3 and you get negative 3. All right, and this is my short leg here. So I get 2 square root of 3. Hypotenuse is always positive. All right, now I can come up with my 6 trig functions. All right, so I have negative square root of 3 over 2 square root of 3 is equal to negative a half. Then I have negative 3 over 2 square root of 3. That is negative 3 square root of 3 over 6, which is negative square root of 3 over 2. Then I have negative square root of 3 over negative 3, which is square root of 3 over 3. All right, so there's the first 3. And then I have cosecant, which is simply the reciprocal, negative 2 over 1, which is negative 2. Then I have secant of x, which is flip what we got before, and we have 2 over the square root of 3. I can put negative here. So multiply top and bottom. I got negative 2 square root of 3 over 3. And then last one, cotangent, which is 3 over square root of 3. So rationalize. All right, so we have all 6 now. On to the next example. Okay, here is where you will begin to apply trig identities all over the place. Now, all the identities you see on your yellow sheet, get familiar with those, because the more familiar you are with them, the easier life will be when working out these problems. All right, example 3, simplify. Let's see, how do we simplify this? Well, this looks a bit complicated here. If you have a square in an expression, then typically you want to look at your Pythagorean identities. Not always, but most often. So let's look at a variation. Find the variation. 1 minus cosine squared. That's equal to sine squared. Okay, so I could replace this with sine squared. And then I have cosecant x. Now, sine squared is the same thing as 1 over cosecant. You could do that and write 1 over cosecant squared. Or I could take cosecant, apply the reciprocal identity, and write that as 1 over sine of x. All right, so 1 sine of x cancels out with 1 on top, so I'm just left with sine of x. Done. All right, on to the next example. All right, here I have a cofunction identity. It's cosine squared. All right, don't forget the little square there. So the square carries over into its equivalent expression. So that's equal to sine squared x over cosine x. Alrighty. And now one thing you could do to simplify this is break this up into 2 pieces. Break the sine up into sine of x over cosine of x times sine of x. Alright, sine of x times sine of x is sine squared. Alright, and then sine of x over cosine of x, that simplifies into tangent using the quotient identity. And at this point, there's nothing else we could do. We've simplified it as much as we can. All right, let's do another example. All right, example 5, simplify cosine squared x, cosecant x minus cosecant x. Well, first thing, notice that we have a cosecant x in both of these here. So I could factor out the cosecant x, and I'm left with cosine squared x minus 1. All right, since we have a square, let's take a look at the Pythagorean identities. Can we match this up with any of them? Somewhat. Okay. Here's one of the identities, or a variation of it. Now I'm drawing this, or writing this out from your yellow sheet. All right, notice what I have on top is cosine squared x minus 1. So the cosine is positive, and then I have the minus 1. From what I've written here, this doesn't come from the problem, this comes from the identity. I have positive 1 and I have negative cosine. So how do I switch those around? Well, just take the identity and multiply negative 1 on both sides. So then I have negative sine squared x is equal to negative 1 plus cosine squared x. Okay, and now these match up. Okay, so I could replace cosine squared x minus 1 with negative sine squared x. All right, so all of this is not part of the problem. This comes from the identity. All right, so I have cosecant x times negative sine squared x. All right, and what comes next? Well, I could apply the reciprocal identity, which gives me 1 over sine of x. I have negative sine squared x. And then that cancels out. Lose one of the sine x's on top, so I'm left with negative sine of x. Done. All right, example 6 here. Okay, so let's see, what's the first thing we could do? I'm going to distribute in this case. Sine of phi cosecant phi minus sine squared phi. All right, don't freak out by this symbol. It's just like x. All right, a lot of new Greek letters are going to come up in this lesson or this chapter. Okay, so what's the next thing I can do? Well, I can apply the reciprocal identity to that function. All right, so these cancel out. I'm left with 1 minus sine squared phi. Okay, and then applying the Pythagorean identity, I could rewrite that expression as cosine squared of phi. All right, nothing else we could do with that. It's all by itself. Done. Okay, now from the past 4 examples that we just did, this may seem quite complicated at first, and I understand that. It just takes a little practice. You need to get familiar with identities, and eventually, start getting easier to see what you should be doing in these types of problems. Okay, if you have any questions, make sure to ask for help. Begin the assignment at the bottom of the page.